Hey there, everyone. My name is Ryan Schul. Welcome to my data science channel. I'm trying to use this platform to create full-time, sustainable, and repeatable and persistent income. So I stepped away from the corporate world for a while, and I'm trying to use this medium to try to generate some money. So hopefully it's successful. I've got some subscribers. I've got about 800 subs right now, which is kind of nice. Kind of excited about that. I don't have enough hours viewed to be able to monetize the channel, but hopefully, God willing, hopefully soon, I'll reach that goal and I'll be able to start making some money here and do this on a full-time basis. That would be my long-term goal. But I guess it kind of depends on how a few things go here. So let's get on with it. Basically, today I want to analyze the intellectual complexity of Obama speeches and Donald Trump speeches. So Barack Obama versus Donald Trump. I want to look at a few different metrics here and basically just analyze the overall structure of the text. Basically, these are called transcripts, and convert that into some type of text that we can feed into a machine learning algorithm and analyze it and study it and be able to quantify how easy it is to understand the person or how difficult it is to understand the person. Okay, so there's a few things that we need to do. We're going to transcribe the speech into text, analyze the language for things such as readability, vocabulary, complexity, things like this, right? We're going to analyze the tone, the sentiment, and the pronunciation of these individuals, right? And why could Obama actually score lower than Trump or higher, right? Why could that occur? Let's look at a few different potential outcomes here. Obama is known for clear, structured, rhetorical speeches, often using short, simple sentences. His speeches emphasize persuasion and clarity rather than complexity, and shorter sentences can have common words that are interpretable by kids in lower grades. So maybe third grade, fourth grade, maybe fifth grade. Short sentences are more appealing to this type of audience, right? If you have something like a college professor giving a lecture, it's probably going to be a lot more advanced. There needs more complex sentences, more advanced words, and different, just a different sort of like audience is tapping into that professor giving a lecture, right? Versus a president delivering a public speech, right? Some kind of public speech and engagement. So why could Trump score different? It could be harder to read, higher grade level. He could appeal to people at a higher grade than third or fourth grade. Now, I already did this analysis. I know how it turns out. I'm not going to ruin it for you. But this may or may not be true in the end, right? He might appeal to people. Trump might appeal to people in lower grades, maybe second grade, third grade. We'll see that in just a bit here. Trump speaks more informally, so very casual. Tends to use run-on sentences, repetition. You see that all the time. I can't do any Trump impersonations. I wish I could. I just don't know how to do it. Only he is really good at that. Although I have a friend that can kind of make an attempt, and it sounds somewhat realistic. So I'm not going to try to act like Obama or Trump, and I'm not a huge fan of either. I think they both have their pros and cons. I think they both have excellent ideas, and I think they both have some crappy ideas too. If you could take all of the excellent ideas from both people, or all the great ideas from all the Democrats, all the Republicans, and somehow combine them together, I think we would have an amazing Congress and a fantastic House of Representatives. It seems like, at least these days, it seems like there's a lot of bad ideas that get picked up and kind of incorporated into the government. But if somehow we could flush those away and just use the good ideas from both parties, Democrats and Republicans, I think we would have a fantastic government. But let's get back on point here. This analysis is more about analyzing the complexity of speeches. Okay, so I'm going to get the information from YouTube. I'm going to go fetch the data from YouTube, pull back what's called a transcript, and then feed that into the algorithm and see how the algorithm processes it and quantifies the results of that transcript. Okay, so that's the point here. So first of all, We're going to import a couple basic libraries here. Okay, natural language toolkit, and we're going to tokenize the words. So when we tokenize words, we take that string of characters, which can be a single word or a sentence or a huge paragraph, and tokenize it. We convert that into numbers that the computer can understand. Once it's tokenized, the computer can do its analysis. The computer doesn't know what bird or dog or boat or airplane is. It has no idea what those things are, right? But if you can tokenize it and train the machine to understand what these tokens represent, then we can do some really amazing things. Okay, so tokenizing all the words is a big part of this thing too. So I have the whole algorithm here. I'm not going to take you through every single piece of it, but basically I'm trying to do a couple things here. Clean up sentences. I'm going to create a place to store this in the computer's memory. This is called a list. You can tell by the square brackets here. And once the sentence has been sort of processed and tokenized and cleaned up a little bit, then we can start to do the analysis. And when I say cleaning, we want to get rid of short words like short words like probably the, things that don't add a whole lot of meaning or purpose to the sentence or to the speech. We want to remove that and just make it more, I guess, more practical and more, what's the word? I guess more practical, right? Because some words don't really add a lot of meaning to the sentence. If a person uses that's not adding any value whatsoever, right? And I just said it right there, right? But if you focus on the words that have more purpose and more meaning, you're going to have a much richer sort of conversation and much richer understanding of the vocabulary and the overall speech itself. Okay, so here's one example right here. I am creating a very simple speech for myself, and I'm going to analyze it. Hello, everyone. Welcome to my YouTube channel. Today, we're going to talk about how to make a great sandwich. Okay, and it goes on and on. Peanut butter and jelly. Don't forget to add some lettuce, tomatoes, and cheese. Okay, because you always want cheese with your peanut butter and jelly. This adds extra crunch. Okay, so I don't know how delicious the sandwich is going to be, but anyways, that is a very practical, short use of words to describe something that's happening. So I just want to show you like fundamentally how these models work. You take this, you can tokenize it, convert it into numbers that the computer can understand, and it's going to print back a couple scores and give us some quantifiable metrics to help us understand a few things about this speech. This is my speech about the sandwich with the peanut butter and jelly and what was it, cheese, right? Okay, so let me run this thing. Okay, Control Enter to run the cell. Okay, so it ran, and it's going to spit out a couple of things here. So Flesch-Kincaid Grade Level. So this is basically going to appeal to somebody that is about between 4th and 5th grade, a little bit closer to 5th grade. Okay, so it's pretty simple, pretty straightforward. Anybody in 5th grade should be able to understand. Hello, everybody. Sandwich. Okay, a 5th grader is going to know what a sandwich is. Peanut butter and jelly, lettuce, tomatoes. They're going to understand it, right? So this is operating, or the language is based on the vocabulary of what a 5th grader could understand. Now, this Flesch reading score 78.45 is pretty high, closer to 100 is perfect. Usually these don't go over 100. If it does, it tends to be like a little bit more cerebral. It's not going to go really over 100 too much, but it could just get just past 100. But usually for a very legible, very comprehensive, very not comprehensive, but easy to comprehend. For something that's easy to comprehend, it's going to be pretty close to 100. Okay, we have something called a Gunning-Fox Index, 4.74, and the SMOG Index, 7.6. Again, these are kind of like the grade level that can understand the complexity of this text over here. Okay, so I have some notes down here. Measures the readability of the text. A higher score suggests more complex tests. Right, so if you get up to 12, that's like a 12th grader. If you get beyond that, that's more like a high school. More like a college level, probably professor giving a lecture or something like that. The second metric that we have here quantifies how hard or how easy the text is to read, with higher values indicating easier readability, right? That's why I said you want to get close to 100. It could go a little bit over 100. Usually they don't, but we'll see what happens in just a moment in a real case. because this is my sandwich example, right? Lexical diversity, this is how diverse the grammar is, okay? The SMOG Index, basically, it's a formal education needed to understand the reading. So again, this is like fourth grader, almost fifth grader. This is the same thing over here. And then the last is SMOG Index estimates the years of education required to understand a piece of text. So these two things are kind of doing the same thing, almost, right? It's like probably a slight difference. So yeah, so let's get into it. Let me show you how this stuff works. Let me save it. I think I have to refresh my page. It looks like something's missing out here because I see nothing on blank space that it shouldn't be. Okay, so let me refresh this guy over here. And we'll look at a real example using an Obama speech and a Trump speech, and I found the Clinton speech, so I have a bonus. I'm going to throw in one bonus speech. Okay, so there's the thing I just did. So we don't have to rerun that. There is some notes about what these metrics mean over here. Okay, so the grade level, easy to interpret, and then the educational level that can identify with that kind of speech, right, or that kind of text. So here is an example of fetching the information from this YouTube video right here. So if I put that in the window, we can see what we're getting right there. Full speech Barack Obama. Okay. And that's it. You can take a look at that. I'm certainly not going to play the whole thing here, but that's the source of the data. Okay. Oops. Okay, let me stop that. Okay, so that's the source of the data, right? And if you look at the transcripts, when I run this right here, you can see the transcript is printed out. Okay. I have one more job tonight. That was Michelle Obama, and there's cheers and applause in the background. And by the way, when you get these things, like I'm doing some data cleaning here because you really have to clean this up. Otherwise, these models get a little bit confused. So this could throw it off a little bit because when people are giving speeches, okay, there could be cheers, there could be background noise, there could be applause. And this kind of overflows into the transcript here. So it's not that desirable. I think the model can handle this and overcome this in a lot of instances. But on these types of things, it might struggle a little bit. Okay, so that is not great. That is not great. Okay, it's background noise. It's a little bit distracting. But all the rest of this is pretty solid text. So I'm pretty confident that we can do some analysis and we'll see what we get. So that's the whole setup, right? Go ahead and fetch the transcript from the YouTube channel. Go ahead and do some cleaning on it. Prepare that to be tokenized, fed into the model, and then the model is going to quantify those like handful of metrics I just showed to you, and then I'm going to print out a word cloud at the end too. So these word clouds are great for visualizing the frequency of words that were spoken, right, or that were analyzed, whatever. In this case, the spoken words, it could be a written transcript too. But the bigger the word and the bolder the word, the more common that word is used. Okay, so let me go ahead and run this, Control Enter, and you don't have to worry about all the code here. I'm going to share this with you. When I post a video, I'll post all the source code. The only thing that you need to really understand, again, this is the source for the transcript, and if you post in any different YouTube link over here for that video, everything will be converted to text as long as it has closed captions, okay? Because there's a couple ways to do this. If you don't get closed captions, like here we have that. If you don't have closed captions on the video, then you have to use a different approach. It's more complicated. I'm trying to simplify it, so I'm using, kind of cheating a little bit here. I'm using closed captions to help me get my transcript. So I'll hit Control Enter. Again, this is Barack Obama, and this was the first attempt. I didn't do a whole lot of cleaning on this text. This is kind of raw. This is just straight up just the way it comes in. Okay, so here's the text, the first 1,000 words printed out. Here's the word cloud. So US, lot, on, way, day, will, put, or used over and over. Again, the boldness and the size of the word corresponds to the frequency of the word. So the more the word was used and the whole transcript, the whole corpus of text, this is body of text, then the bigger these will appear and the bolder they will appear. So we have average sentence length, 8.45 words, median sentence length, 8 words, Flesch-Kincaid Grade Level, -1. Now I think this is coming up -1 because the model doesn't really know how to handle this. Applause, that gets it tripped up. And these are very finicky. So I'll see a couple things like that. And you look back here and you saw applause a couple of times, right? So the model probably needs a little help just handling these types of things, right? Which is a little bit unfortunate, but it is what it is. Like if background noise is coming in, the model is going to get a little bit distracted by that. There's another distraction here. There's another distraction over here, right? So I think that is why it's saying -1 grade level, because there's really no -1 grade level, right? That doesn't exist. So the model is doing a decent job. I think it's getting tripped up by the applause and the cheering in the background. So we could probably refine it, maybe just delete those types of words. I didn't do that in the first attempt. And the second attempt, you'll see below, I did try to clean that up. But this is a pretty decent score. Remember, it goes close to 100 if it's very coherent, very well spoken, very well delivered. That scores close to 1.0. Ease of understanding, that's what that is. And lexical diversity can go up to 1.0. So the more diverse the text is or the transcript, this is going to go higher and higher as you get close to 1.0. You would just use more diverse types of words, right? So is that desirable to have a diverse set of words? Maybe it is, maybe it's not. In a presidential speech, you probably want something in the middle. You want it to be very, very diverse and like all over the place. You want it to be kind of contained and kind of relevant to the topic, right? So I think these scores are fine. The first one looks a little bit wacky here, I'll admit. I think it comes from the distortion that we see. Things like this are tripping up the model. Overall, the level of education that Barack Obama here is speaking to is about almost fourth grade, and here is a different way of getting a similar metric. This says this kind of speech is appropriate for a fifth grader. So somebody in the fifth grade can probably identify with this language pretty easily. Okay, so that is Barack Obama first attempt. This is second attempt. Now I added a little bit of cleaning to the second transcript here. Same exact speech, right? If you look here, again, it's coming from this right here. That's the data source. So I'll put that over here. You'll see it's the same thing. Okay, so the only thing that changed is the adding cleaning now, right? To try to get rid of some language that just is kind of tripping up the model. Okay, so we're gonna give the model some help, give it some assistance here, and just do some cleaning. So let me go ahead and run this. Okay, Control Enter to run. Barack Obama, second attempt, and let's see what the scores come back with. Here's the text again. The whole transcript. Now we're getting 1.6. So again, somebody in first grade, it seems kind of low, but it's okay. I think the model is still getting tripped up by a few things, and we really want to be cognizant of removing these words that can be distracting. So words like the, long pauses, applause, cheering, that doesn't help the model. But after adding some cleaning, we got under 100, right? So I think the model was getting a little bit distracted by those other things. Now this is a pretty solid score. Close to 100 is good. Lexicon diversity, 0.28. So it might be a little bit low, not super diverse. But again, for a presidential speech, maybe it's fine, right? Maybe 0.20 to 0.50, somewhere in that range, I think is fine. And over here, using a different metric, instead of a first grader, this would be assuming that a first grader would identify with this. This is a third grader, and this is a fifth grader, almost sixth grader. So I think these are coming back. This one looks a little bit suspicious, but overall, I think that's fine. Now, and with the cleanup words, you see applause. Yeah, that should probably be taken out. I didn't do that. I kind of want to leave that in at this point, but if you feel like you need to get rid of that, by all means, go ahead and do that. You can easily add that into a list right here, filler words. If you want to remove that, it might clean things up and then just make it a little bit easier for the model to learn, right? You just add the NAPPLA, APP, applesauce, no applause, I can just run it just for fun. Just run it and see. Okay, so rerunning the model. Let's see what we get. 1.6 didn't change. Okay, so the plus really isn't really throwing it off. I think we're fine either way. So here's the bonus. Bill Clinton, again, Everything is exactly the same. The only thing I changed right here was this link so we can get the Bill Clinton speech, right? Obviously, it's not going to be Obama. It's going to be Clinton this time. Okay, so there's the source for the data. Okay, let's run the metric. And remember, this is really Obama and Trump. This Clinton thing was just a bonus. I just picked that up and threw that in there. But let's see how well the model does training and testing of a Bill Clinton speech. Okay, so let's see what it comes back with. And here's the text or the the transcript. Right, there's a transcript, and it's all printed out. That looks kind of nice right there. Let's get down to the metrics. So this now appeals to a much more mature audience. This is someone in 14th grade. So 12th would be high schooler. This would be a sophomore in college, right? So sophomore in college, 47.35. So easy, ease of reading. So scoring lower than Obama. It just means that this is an easier speech to read or to comprehend in terms of easy to comprehend. That's all it's measuring. And lexical diversity is actually a little bit lower than Obama's 0.22. So probably a little bit tighter, a little bit crisper, not super diverse. And again, that's probably fine. These two metrics kind of jive with this one over here, 14th grader. So this is going to be a sophomore in college. And this is the word cloud and the frequency of words. Again, we're plotting the frequency that these words were used in the transcript. Okay, now let's move on to Donald Trump, and we'll do the same exact analysis. Let me get that going. This will run in a couple of seconds, pretty fast. And this comes from this speech over here. So put it in, and you'll see Trump over here. And again, I kind of probably would lead towards Obama over Trump, but I'm not going to take sides here. I'm not going to be biased. And everybody has an opinion about who could be a better president, things like this. Honest to God, I just wish that people in Congress and the House would just work together, collaborate more, and come up with great ideas and pick the best ideas from the Democrats, but pick the best ideas from the Republicans and use both and combine those and use both. Get rid of the waste, the nonsense, the stuff that is superfluous and extra and unnecessary, and all the fighting and bickering and debating. Like most of that is just nonsense. If you could take the best ideas from the Democrats, the best ideas from Republicans, combine those, I think we would have a fantastic government. For some reason, they can't do that. Not sure why, but it doesn't work like that. Anyway, so here's the Trump speech. I just ran it. I'm 100% certain I just ran it. I'll just run it again. Okay, and let's look at the results. So here's the transcript down here. Okay, and where's my metrics? So we'll get the word cloud, and we'll have our 5 metrics printed out down here. So average sentence length, 266.4, and median is 71. Now this clearly is broken at this point. Okay. But I think the model is getting seriously confused because you know that Trump likes to run on and on and on and on and on and on, and it just never ends, right? So I think there is a problem with punctuation. Maybe the cleaning needs to be done slightly differently, but we did it for Clinton and we did it for Obama, and both times it came up pretty squeaky clean, and we got some good analytics. At this point, when we get to Trump, the model just falls down. It's flat in its face, and this thing is basically broken. The sentence can't go on for 266 words, but you can see here we have no punctuation, so it seems like it just runs on and it never stops. So this speech this transcript has to be handled a little bit differently. It's just not normal, so has to be interpreted different and just managed slightly differently. Now the grade level is 95. This would mean you are in grade 95, which would essentially be like 100-year-old person, I think, if you stayed in school your entire life. So that also is broken. That metric just isn't working. Reading Ease score, is that even right? Is that negative 158? The first time I thought it was positive 158. Let me copy this thing. Is that actually, my eyes are not so good. Is that actually negative? Like, I didn't even know that I could even do that. Well, let's see. Okay, let me paste this into Word and just see. I just want to blow it up a little bit. Control V. Yeah, that's a negative vowel. Okay, so again, like this speech is just not normal. And the model is just falling down. It's basically broken at this point, and it doesn't know how to handle this. In terms of diversity score, I think this one actually is working. So the language isn't very diverse. It's kind of the same rhetoric over and over and over. Trump likes to repeat himself. And that's it. I mean, it's just a very different kind of brand, I guess. The Trump brand is very different from other presidents. Okay. So that's fine. This is way too high. I would say the model just can't handle this as is. Like we would need additional treatment on the transcript and just handle the text differently. This thing isn't working. I think this probably is somewhat accurate. And again, this is not working too. You can't be in grade 98. You go up to 12th grade if you don't go to college. So 13, 14, 15, 16, if you go to college, you could be in grade, I guess if you go to grad school, maybe it's called grade 18. I don't know if it's really called grade 18 at that point. You can't have a grade 98. That doesn't exist. So that is bizarre. And this, if we had a grade for that, that would probably be a postdoc or maybe a doctor or maybe a lawyer getting a master's and a JD, something like that. You maybe could have a grade 28 potentially, but the rest of these just simply don't work with the Trump speech. So very, very different way of thinking, talking, acting. We're trying to understand the complexity overall of these different types of speeches. I gave you three, right? Trump, Obama, and Clinton. And Trump and Obama are kind of like mainstream, kind of similar, kind of like what you expect. And Trump is just like left field, doing some very different things. I'm not going to say anything negative about the guy, but definitely like the standard approach to analyzing text doesn't work in the case of Donald Trump. So I'm sorry if you're a Trump fan. I'm not saying anything bad about the guy. Like he can take care of that all by himself, but definitely different than what you would normally expect. Okay, so that's it, guys. So I'm going to wrap it up at this point. I will post a video pretty soon. I'll share all this code with you. Of course, you can copy and paste this into your Jupyter notebook and create your own analysis. And then again, like the main thing here that you need to change, the only thing you need to change is this right here. If you want to analyze different types of speeches from who knows what, Bernie Sanders, or even like a non-politician, that's fine too, right? You just change the link, change the source for the transcript, pull that in, make sure that it does have closed captions, okay? Because there's two ways of doing this with CC. If there's closed captions available in the video, then you can use this approach. And if not, it's going to come back with nothing, right? Because this approach that I'm using right here, this technique, looks for those closed captions. That's how you get the words. But that's the easier way to do it. The other way is way more complex and convoluted, and I just didn't want to go down that whole path. So I like to keep things as simple as possible, still make it work, right? But not overcomplicate it. But it, of course, it has to be complex enough to handle the analysis and to answer the question that you're trying to answer, but you don't have to overcomplicate it just for the sake of complicating things, right? So we try not to do that. So that's it. I'm going to wrap it up. I will post a video and all the source code, and I'll see you guys in the next video. Thanks for your time. Goodbye.